All right, another video lesson. Um, Hopefully this is the last time I'll be gone. Um, so we're talking about the angles that we looked at in section 3.1. Um, Consecutive interior angles. Okay, remember those are also called same side interior angles, which would be 2 and 5 and 3 and 8. Okay, those are the only sets of angles that are going to equal 180 degrees besides a linear pair. Okay, so consecutive interior angles are supplementary. Okay, and you're going to need to write these postulates and theorems down when we look at the problems. Theorem 3.1, alternate interior angles are congruent. So 2 and 8 and 3 and 5 have the same measure. Corresponding angles are congruent. 4, 8, 3, 7, 1, 5, and 2, 6. And alternate exterior angles are congruent. So 1 and 7 and 4 and 6. Okay. So we're going to identify which angles are supplementary to 3 and how we know that. What I mean by how we know that, what theorem or postulate lets us know that that's the case. So you're going to need to refer back to that first sheet. Okay, so angle 3. Think about what angle is a consecutive interior angle with angle 3. Okay, that would be angle 8. Okay, so that would be supplementary to 3. So we would take 180 and we would subtract 55 to get the measure of angle 8. Okay, so angle 8 would be 125 degrees. It does not ask us for that, I'm just showing you. Okay, what's another angle that would be supplementary? What other angles with angle 3 would add up to 180 degrees? Okay, look for a linear pair. How about 3 and 4? Okay, 3 and 4 make that line. So, and what about this? What about 2 and 3? 2 and 3 would also make a line. They'd make a linear pair. Okay, and so for those, I'm just going to put a linear pair because we've already had that definition, so we can use it when we need to. So 8, 4, and 2 are supplementary to angle 3. Okay, now it's asking us which angles are congruent to 3. So which angles have the same measure as 3? Okay, so let's think about alternate interior angles. So what makes an alternate interior angle with 3? Okay, that would be number 5. Whoops. Okay, what else do we know? What about corresponding angles? What angle corresponds with 3? So 3 is below the line, so that would be angle 7. Okay. There's another one that's congruent to 3 that you might not think about. Okay, how about angle 1? Okay, 3 and 1 are vertical angles. And we know that vertical angles are congruent because we had that theorem or postulate before. Okay, so those are the 3 angles that would be congruent to 3. Okay, what about to number 1? Okay, what angle corresponds with 1? What's a corresponding angle with 1? Okay, that would be angle 5. 1 is on the outside of the parallel lines, so remember, that would be our internal. So an exterior angle alternate exterior angle would be angle 7. Those would be congruent. And then what about 3? Because 3 is a vertical angle to 1. So those 3 angles are congruent. Okay, we're kind of repeating ourselves when we have angle 7 here. So that's okay, let's just see. So 7, what would correspond with 7? Angle 3. Those are congruent. Okay. 7 and 5 would be vertical angles. Those would be congruent. And 7 and 1 are alternate exterior angles, and they would be congruent. Okay, so the only two that aren't congruent are the consecutive interior, or same side. Okay, those, remember, equal 180 degrees, because they basically make a linear pair. Okay, now we're going to find measures. On your sheet, you do not have the angle 3 in your diagram, so go ahead and put angle 3, which is right here. Go ahead and put that on your diagram so you can see what's going on. Okay, so I'm going to find the measures of 3 and 4 and say which theorem or postulate justifies my answers. Now, if I were to turn that figure and look at it kind of upside down, 4 and 105 are consecutive interior angles between L and M. So we know consecutive interior angles equal 180. So 180 minus 105 is 75. So angle 4 would equal 75 degrees. Okay? Now we need to know angle 3. Okay, there's different ways that you can think about this. 3 and 4 make a linear pair, and 3 and 105 are vertical angles, so they would be congruent. So my answer would be 105 for that one. Okay? So just remember, if you're looking at a linear pair or consecutive interior angles, then they're going to be 180 degrees. Alternate exterior, alternate interior corresponding are all congruent. Okay? So let's erase that and look at 2, 8, and 1. So angle 8 is a corresponding angle with 105. So angle 8 would be 105 degrees. Oh, I forgot to say. So that would be theorem 3.2. 4 would be postulate. Postulate 3.1, consecutive interior, and then this would be theorem 2.1 from way back, vertical angles. Okay, angle 2. Okay, whoops. Angle 2 would be a linear pair with 8. So we take 180 minus 105. Okay, and that's just because we know it's a linear pair. Okay, and then angle 1. Okay, now another couple ways you can look at this. Okay, 1 and 2 are vertical angles, so they would be the same. 1 and 8 are supplementary. So angle 1 would be the same measure because of theorem 2.1, which is the vertical angle theorem. I don't expect you to remember that all the time. I forgot to give you a sheet that kind of listed what we have so far, but I'll do that on Monday. So you have that. Okay? So simple. We're just finding angle measures and listing what postulate or theorem they are. Okay. Finding the value of y. Okay, this one might be a little bit more confusing, but let's look at let's think about extending these lines a little bit. Here's our parallel line, here's our transversal. Okay? Oh, that's really kind of sloppy. Anyways, so let's try to make this a little bit neater. There we go. And then oh yeah, that's whatever. So if you look at 40, this angle here would be an alternate interior angle with 40. Okay? So that means that that measure right here is 40. Okay? So y has to be whatever 40 and or 180 minus 40. I think I'm doing that wrong. Yes. So I hope you're writing in pencil. I had a moment there. So basically with these, all you have to do, it's simple, I made that way too difficult, is we take these two measures, which is 120, and we minus that from 180. Okay, because 80 and these two angles together would make consecutive interior angles, and that would be 180. So the value of y would be 60. Well, I made that way more complicated than I needed to, but just think about it that way. Okay, so then same with this. 50 and 60 plus y. So let's look at it like that. Those would be consecutive interior angles, all three together would equal 180. Okay, so that would be 110. You don't need to set up an equation like this. I'm just showing you how I get to the answer. So y would be 70 degrees. I won't put anything like that on your test, just the stuff before and then the stuff that we're going to do. Okay, we're going to find the value of x. Okay, sometimes this gets a little tricky, but we'll get through it together. So I need to find a nice pink shade. There. So we're looking at that figure A, and first of all, these arrowheads right here mean that those lines are parallel. Okay, so if we think about extending these, and I don't want to write over my, okay, this guy right here would be my transversal. So I hope you can see, not after I just highlighted over it all, I hope you can see that these two then are consecutive interior angles. After I've made my lines bigger, it's much easier to see. Okay? So extending those lines helps a lot to see what's going on. So let's just make that nice again. right, so those two are consecutive interior angles, and according to postulate 3.1, they add up to 180 degrees. So that's exactly what I'm going to do. Okay, and then it wants me to find the measure of each labeled angle. Let's solve for x first. So 2x minus 50 is 180. Okay, add 50 to both sides. Two x equals 230. And what is 230 divided by 2? 115. I'm going to run out of room. Okay, there's x. Okay, now it wants me to find my angle measures. Okay, so I'm going to plug x back in. Well, if x is just there, then I know that this angle here is 115. And then to find that, I would take 115 minus 50. That would be 65 degrees. And that would be that. Do they total 180? Yes, they do. So we did it correctly. Okay, so again on the next diagram, looks like we've got a triangle, but let's extend these parallel lines. And I know they're parallel again because they have the arrowheads. That's what that means. So this would be our This would be my transversal. So these two angles, okay, they're both on top of the parallel lines, so those would be corresponding. Corresponding angles, I know, according to Theorem 3.2, are congruent. So what do I do when they're congruent? I set them equal to each other. Okay, subtract x. Okay, add 10. Okay, divide by 2, x is 25. Okay, now it wants me to plug it back in for the angle measures. Okay, so 25 times 3 is 75 minus 10 is 65. Okay, well this angle right here better be 65, and it is if you add 40. Okay, so they end up to be congruent. Okay, sometimes flipping your page helps too to look at the lines. But like I said, extending them really helps a lot. Okay, this one's easier to see, obviously, because it's right where we need it to be. Let's get a pretty purple. Okay, so what kind of angles do we have in C? Okay, well, I know for a fact they're in the inside, they're between the parallel lines, and they're on opposite sides of the transversal. Okay, that would make those alternate interior angles. Okay, and according to Theorem 3.1, I know that they're congruent. So again, I will set them equal to each other. So subtract 3x. Okay, add 2 to both sides, and x is 18. Okay, so let's plug that back in to x. You can just do one, but if you want to check your work, then do both of them. 18 times 4 minus 2 is 70. Okay, so this angle here is 70, and this angle here is 70. Okay, if for some reason you get a different answer, you need to go back and check your work. For some reason, if you plug it back in, 1 is, oh, no wonder. All right, who caught my error? Okay, this is not 16, it's a 6. Lord, I hope you guys are doing this in pen. Pencil. Wow. So now if I add 2, oh goodness, x is 8. So this is 30, and this is 30. Okay, I was like, that does not match up. One was coming out as 60, one was coming out as 70. So that's why, because for some reason I brought down a 1. And that's why we're all human, because we make mistakes. Some of us, like me, more than others. Okay, what kind of angles are these? Okay, well, they're on the same side in the interior, so they're same side interior, or consecutive interior. And we know, according to postulate 3.1, those are supplementary. So what do? We know that they add up to 180 degrees. Now those are the only ones besides linear pairs that add up to 180. So don't mix that up. They have to be on the same side of this line here, on the inside, and they are. So 5x plus 20 by combining like terms, 180. So 5x is 160. Divide both sides by 5, and you get coffee spilt. That's just what happened. 32. Okay, so we need to plug that back in. So this angle would be 69 degrees. And you can either plug it back in or take 180 minus 69. And you should get 111. Okay, so then this angle is 111 degrees. Okay, I hope I did not lose you too much with that mistake. If I did, I'm sorry. Okay, so our last slide is a proof, which I know is really hard for you guys. Okay, I understand that. What I want you to do is try your best. Okay, you have to look at what the statement is saying to you. Okay, I gotta get that off the screen. Okay, so watch what the statement is saying. It makes a big difference in the long run. Okay, so let's just read up top. Given A is parallel to B, and we need to prove 1 and 8 are supplementary. Okay, well that's fine. My first statement says A is parallel to B. That's my given. Okay? Now, we're going to use the postulates and theorems that we got this section. So the first page will be important. Okay, so now it tells me 1 is congruent to 5. Okay, look at what kind of angles those are. Okay, 1 and 5 are corresponding angles. Okay, what does that mean? Well, we know that they're congruent because theorem 3.2 tells me they are. Oh, I lost the little end to my stylus. Okay. Okay. Sorry, I lost the little end to my stylus there. Okay, so given. Okay, so theorem 3.2 says corresponding angles are congruent. Okay, so why can we say measure 1 equals the measure of angle 5? Well, because we know that congruent angles equal measure. Okay, definition of congruence. Okay, so remember that if something is congruent, it is equal in measure. Okay, now it's telling me 5 and 8 are supplementary. What do they make? Okay, you guys have to understand what these angles are and how to find them. Those two angles make up this line here. So they're a linear pair. We know that's 180 degrees, or supplementary. So we're going to say linear pair. Okay, now it says they're 180 degrees. Okay, well we know that. That's what supplementary means. Okay, so we'll put definition of supplementary angles. Okay, now sometimes you got to go back and look at things to figure out what's going on. So they tell me this. Okay, well I know 5 and 8 are 180 and that 1 is congruent to 5. So what am I doing when I put 1 in there instead of 5? Okay, I'm using substitution. Okay, now I can say they're supplementary because I know they're 180 degrees. That's the definition of supplementary angles. Okay, so even if you don't get through this video lesson, you still need to finish it at home and do the worksheet because I'm expecting Monday when I come that the worksheet is done and we can move on. So have a good day, and that's all I've got.